Hi friends, good morning. Please look at the next problem. Friends, this is problem number 1 of exercise 15.1 of chapter probability. These are only basic questions related to the introduction of probability. Let us see the first question. See, probability of an event plus probability of the event not E is equal to probability of an event and plus probability of not E is equal to question mark. Friends, see, I shall consider one example. Suppose if you throw a die, if a die is thrown, what are the possible outcomes? Total number of outcomes 1, 2, 3, 4, 5, 6. Then what is the probability of getting 5? What is the probability of getting 5? So probability of getting 5 is equal to favorable outcomes 1, total number of outcomes 6. 1 by 6 is the probability of getting 5. Then what is the probability of not getting 5? probability of not 5. Probability of not 5. So probability of not 5. How many outcomes are favorable for not getting 5? 1, 2, 3, 4, 5. So other than this 5, remaining 5 or 5 elements are favorable for not getting 5. So for not 5, the probability is 5 by 6. So now P of getting 5 plus P of not getting 5 is equal to, then P of 5 plus P of not 5. P of not 5 is equal to 1 by 6 plus 5 by 6, that is equal to 6 by 6, that is equal to 1. So every time probability of getting an event plus probability of not getting an event, so is always equal to 1. So PE plus P not E is always equal to 1. That is the first question, friends. Next, second question, the probability of an event that cannot happen. The probability of an event that cannot happen is impossible event. And its probability is 0. The probability of an event that cannot happen, that is 0. Example, suppose a die is thrown. If a die is thrown, what are the possible outcomes? 1, 2, 3, 4, 5, 6. So if a die is thrown, what is the probability of getting 7? Then it is impossible event. If a die is thrown, the only possible outcomes are 1, 2, 3, 4, 5, 6, any of these 6 numbers. If you want 7, that event will not happen. So such events are called impossible events, and the probability of impossible event is 0. So the second question answer, the probability of an event that cannot happen is 0, and such events are called, and such an event is called impossible event. So if you take an example, getting 7 when a single die is thrown, that is an example, that is an impossible event, the probability of which is 0. Okay friends, let us consider the third one. The probability of an event that is certain to happen, that is sure to happen, is always equal to 1. The probability is pakka, that will happen. So the probability of an event that is sure to happen is 1, and such an event is called sure event or certain event. The probability of sure or certain event is equal to 1. So if you take an example, see a die is thrown, what is the probability of getting 6 or 5 or 4? So that is a sure event. Or if a coin is tossed, what is the probability of getting head or tail? So if a coin is tossed, you will definitely get either head or tail. So that is a sure event, that the probability of which is 1. In the same way, if a die is thrown, what is the probability of getting a number? 1 to 6. 1 to 6. So if a die is thrown, definitely you will get a number from 1 to either 1 or 2 or 3 or 4 or 5 or 6. So such type of events are called sure events or called certain events, and the probability of those events is 1. Next, fourth question, friends. The sum of the probabilities of all the elementary events of an experiment. So the sum of the probabilities of all the elementary events of an experiment. See, elementary event means the outcomes of an experiment. Elementary event means the outcomes of an experiment. Suppose a coin is tossed. Head and tail are possible outcomes, and head is called elementary event and tail is called elementary event. In the same way, if a die is thrown 1, 2, 3, 4, 5, 6, these are the elements of sample space, and these are called elementary events of that experiment. So here the question is the sum of the probabilities of all the elementary events of an experiment. Suppose the experiment is throwing a die. The experiment is throwing a die. So the probability of getting 1 plus probability of getting 2 plus probability of getting 3. These are the elementary events of the experiment throwing a die. So P1 plus P2 plus P3, P4 plus P5 plus P6. So this is sum of the probabilities of all the elementary events. Probabilities of all elementary events. So P of 1 is how much? 1 by 6. So in the same way, P of 2 is also 1 by 6. P of 3 is also 1 by 6. 1 by 6 plus 1 by 6 plus 1 by 6. So this is equal to 6 by 6 is equal to 1. So for the fourth question, your answer is 1. The sum of the probabilities of all the elementary events of an experiment is always equal to 1. In the same way, if a coin is tossed, what are the two outcomes? Head or tail. So the probability of getting head is 1 by 2. The probability of getting tail is also 1 by 2. So 1 by 2 plus 1 by 2 is equal to 1. So the sum of the probabilities of all the elementary events of an experiment is equal to 1. Elementary events means the outcomes of the experiment. That is the elements of sample space. Okay, friends, let us see the next problem. The probability of an event is greater than or equal to and less than or equal to. See, friends, the probability of an impossible event is 0. The probability of an impossible event is 0, and the probability of a sure event is equal to 1, and hence the probability of any event greater than or equal to 0, 0 less than or equal to probability of an event. So the probability of any event will be greater than or equal to 0, but less than or equal to 1, because the maximum possible probability is the probability of sure event is 1. So the maximum possibility of any event cannot be more than 1 or less than 1. So for the fifth question, your answer is 0 less than or equal to probability of an event less than or equal to 1. So probability of an event PE greater than or equal to 0, less than or equal to 1. Okay, friends, thank you. Have a nice day.